Hi everyone, welcome to AI Crack channel. This is Akash Kangwar and today we'll be studying Binomial Lecture 3. So we'll be talking about application based problems of binomial and also we'll be starting with the basics of series expansion. So let's start the lecture. So we'll be looking at three types of problems: divisibility and remainder, integral and fraction part, and comparing numbers and expressions with larger powers. Okay. So let us start with the first and we'll directly see the problems because these are the kind of problems you'll get in the examination. So let's start with this problem. For all n belongs to natural numbers, 2 raised power 4n minus 15n minus 1 is divisible by. Now we can see three types of terms over here. The first one is exponential term, second term is a linear term, third term is a constant term. And there is no commonality between all of them so that we can find out some common factor which is divisible by 225 or 125 or 325, right? So what we'll be doing, we'll be using binomial expansion over here. Now we have 15 over here and we can take a hint from here that if I expand 2 raised power 4n by doing 1 plus 1 raised power 4n, that won't make much sense because we'll not be getting anything related to 15n. But what if I write 2 raised power 4n as 16 raised power n, and further I can write it as 1 plus 15 raised power n. So that might help in eliminating these terms and we can find some common factor based on which we can find out the divisible the number which is with which this entire expression is being divisible, right? So let's try to find out this expression. So 1 plus 15 raised power n is equals to nc0 dot 1 raised power n dot 15 raised power 0 plus nc1 dot 1 raised power n minus 1 dot 15 raised power 1 plus nc2 dot 1 raised power n minus 2 dot 15 raised power 2 and till ncn dot 1 raised power 0 dot 15 raised power n, right? This is n. Now if I try to simplify it further, this is nc0 is 1, 1 raised power n is 1 and 15 raised power 0 is 1. So basically the first term is 1 only, plus nc1 is n dot, this is 1 only and this is 15. So second term is 15n. Now I can see 15n in the term. The third term would be nc2, which is some integer dot 1 multiplied by 15 square and so on so forth. The n term would be ncn dot 15 raised power n. Now the actual term was 2 raised power 4n minus 15n minus 1. So that was 1 plus 15 raised power n plus, minus 15n minus 1. Now we have actually got this term. So 1 plus 15n plus nc2 dot 15 square till ncn dot 15 raised power n minus 15n minus 1. So this and this gets cancelled and this also gets cancelled, right? So we are getting some integers multiplied by 15 square plus some integer multiplied by 15 cube plus some integer multiplied by 15 is per n. So basically I can see 15 square is a common term. nc2 plus nc3 dot 15 till ncn dot 15 is per n minus 2. Now we might not know this term is divisible by 15 or not, or by any other number, we might not know, but we definitely know for sure that this entire expression is absolutely divisible by 15 raised power 2. So basically our answer is 225. Now let us look at this example. What is the remainder when 5 raised power 99 is divided by 26? Now again, we have a different number over here and we have a different number over here, and there is kind of no correlation between, at first instance, there is no correlation between these two numbers, 5 and 26. But what if I write 5 raised power 99 as 5 dot 5 raised power 98, and that would become 5 dot 25 raised power 49. Now I can see some kind of correlation, just like in the previous example. What we did, we tried to relate 15 and 16 from here. So similarly, I can try to relate 25 and 26. How can we do that? That would become 5 times 1 plus, 26 minus 1 raised power 49. And that would give me some kind of numbers in terms of 26, right? Now I can definitely see if it's divisible by 26 or not. And if it's not, then what is the remainder, right? So let's try to write this expression. So 5 times 26 minus 1 raised power 49, and that is equals to 5 times 49C0 dot 26 raised power 49 dot minus 1 raised power 0 plus 49C1 dot 26 raised power 48 dot minus 1 raised power 1 till 49C49 dot 26 raised power 0 dot minus 1 raised power 49. Okay, so this is the term. Now, except this last term, every other term will be having a factor of 26 because this is 26 raised power 49, this is 26 raised power 48, and before this, the penultimate term would be 26 raised power 1 dot minus 1 raised power 48 multiplied by 49C 48, right? So that would also be having a factor of 26. But this last term will not be having. So every other term is divisible by 26. So we can write this in two parts. So that would become, so basically 5 times 26 minus 1 raised power 49 equals to 5 times some 26 times k plus 5 times, and this term is, this is 1 dot, this is again 1, and this is minus 1. So basically minus 1. Now that would become 5 dot 26 dot k minus 5. Now we can see that this term is divisible by 26 and this term is not. So basically this is a remainder, but we cannot report negative remainder. So we'll add, I'll take 126 from here. So basically one factor of 26 from here and add it to it. So that would give me 26 minus 5, that is 21. So 21 is our remainder. Now let's start the discussion of the second category of questions, that is the integral and fraction part questions. So the question is, the integer part of 3 plus 2 root 2 raised power n is an even integer or integer 0, and nothing can be said. So before starting with that, we must know that any fractional number or fraction part function, we know that the range of this f is less than 1 and greater than equals to 0. We know that, right? And also, you know that, let's say I'm talking about 2 root 2 over here. So 2 root 2 is 2 multiplied by 1.414 dot dot dot, and that gives me 2.828 dot dot dot. So this can be further written as 2 plus 0.828, right? Now this portion is called as fractional part, or f, and this called as I. So I can write any number of this kind of format in two parts. The first is integral part and the second part is fractional part. So let's say 3 plus 2 root 2 raised power n equals to I plus f. I is the integral part, f is the fraction part. Now, if I try to write 3 minus 2 root 2, and if I do the rough calculations, I'll be getting 3 minus 2.828. Again, the difference between them is a fractional quantity because that comes under the range of 0 to 1, right? So any fractional number raised per some integer, that would also be given positive integer, that too positive integer, that would also become a little lesser fractional number, right? So let's call that as f dash, and this is f dash, right? Now if I try to add both of them, what I'll be getting, let's try to expand 3 plus 2 root 2 raised per n first. I'll be getting nc0 dot 3 raised per n dot 2 root 2 raised per 1, sorry, 0, plus nc1 dot 3 raised per n dot 2 root 2 raised per 1 plus n plus nc2 dot 3 raised per, it's n minus 1 over here, n minus 2 dot 2 root 2 raised per 2, and till ncn dot 3 raised per 0 dot 2 root 2 raised per n, right? And similarly, if I write 3 minus 2 root 2 raised per n, I'll be getting nc0 dot 3 raised per n dot 2 minus 2 root 2 raised per 0 plus nc1 dot 3 raised per n minus 1 dot minus 2 root 2 raised per 1 plus nc2 dot 3 raised per n minus 2 dot minus 2 root 2 raised per 2 till ncn dot 3 raised per 0 dot minus 2 root 2 raised per n. Now if I add both of them, I can clearly see that this term and this term will get cancelled because it has a negative number over here, and that too raised to power, which is an odd number. So if one is an odd number, similarly you'll get terms minus 2 root 2 raised per 3, minus 2 root 2 raised per 5. So those terms will get cancelled if I add both of them. So I'll be getting I plus f dash equals to 2 times these numbers nc0 dot 3 raised power n dot 2 root 2 raised power 0 plus nc2 dot 3 raised power n minus 2 dot 2 root 2 raised power 2 till nc till the end. We don't know n is an even number or an odd number, so till the end we cannot write the number over here. Okay, so but the main point is you're getting some integer over here. These are all the integral numbers and multiplied by 2. So basically this is an even integer, and if this is an even integer, so this should also be an even integer. So that would be I plus f dash should be even integer. So basically f plus f dash should be integer because this is integer. So this summation should also be integer to make this an even integer, right? So f plus f dash should be an integer. Now f is always less than 1, and also f dash is always less than 1, and greater than 0, greater than 0. If I add both of them, the only possibility of the summation is f plus f dash would be 1. So they are nothing but they are equals to 1. So I plus 1 equals to some even integer. So I should be odd integer. So I was the integral part of 3 plus 2 root 2. So that is an odd integer. So this is a very standard process to solve such questions. In every type of question of this sort, you have to start with this only. Now let's look at the third category where we have to make the comparisons of the numbers. Now you must be seeing that 3 plus 2 root 2, 3 minus 2 root 2. So basically 1 plus x, 1 minus x, these kind of terms come in handy a lot in a lot of problems, right? So even over here, if I try to see that, I'll see 100 minus 1 raised power 50, 100 raised power 50, and 100 plus 1 raised power 50. And I'll have to do something of subtraction and addition in these terms to find out the conclusion. So let us start with this question. Larger of 99 raised power 50 plus 100 raised power 50 and 101 raised power 50 is. So now remember one thing, whenever we compare two functions, two different kind of functions where we cannot, just directly do it mathematically in a normal process. For example, if I'm taking two functions e raised power x and I'm taking the other function as x square, and if I have to compare both of them, which one is bigger at certain value of x, what I'll be doing, I'll be generating a new function fx, that is e raised power x minus x square, and I'll see at what values the difference is becoming positive and the difference is becoming negative, or I'll try to differentiate and do the AOD thing, right? So this is a very standard process. Now over here we have to make certain comparisons. Now we also know that if I write this as 1 plus 100 raised per 50, and if I write this as 100 minus 1 raised per 50, and if I do addition or subtraction over here, then definitely I can make a comparison. But in this case, we have to make the comparisons, so that is why I'll be subtracting, and that might give me some kind of conclusion, right? So that is my hypothesis to start with. So let's write 101 plus 101 raised per 50 as 1 plus 100 raised power 50, and that would be, let's try to write the opposite. That would give me 100 minus 1, 100 plus 1 raised power 50. Now that would give me 50c0 dot 100 raised power 50 dot 1 raised power 0 plus 50c1 dot 100 raised power 49 dot 1 raised power 1 plus 50c2 dot 100 raised power 48 dot 1 square, and till 50c50 dot 100 raised power 0 dot 1 raised power 50, right? Now similarly, if I write 100 minus 1 raised power 50, I'll be getting 50c0 dot 100 raised power 50 dot minus 1 raised power 0 plus 50c1 dot 100 raised power 49 dot minus 1 raised power 1 till 50c50 dot 100 raised power 0 dot minus 1 raised power 50. Now I'll subtract both of them. I'll do the subtraction. Now in the previous case we did the addition, so that is why the odd terms got added. The terms with the odd powers got added. But over here, since we are doing the subtraction, so terms with the even power, so the 0 power, 2 power, they'll get cancelled because minus 1 raised power 0 is 1 raised power 0 only. So the remaining terms are same, so this will get cancelled out. So this term and this term will get cancelled out. this term and the over here second term will get cancelled out, and the terms with the negative power will get doubled, right? So the difference would be, so basically I'll write it like 101 raised power 50 minus 99 raised power 50. That would give me two times of this 50c1 dot 100 raised power 49 dot, just don't write 1 because it's 1 raised power something. Similarly 50c3 dot 100 raised power 47 till 50c49 dot 100 raised power 12. So these are the terms we'll be getting. Now if I just try to look at this number, so let's rewrite it in the new page. 101 raised power 50 minus 99 raised power 50 equals to, we're getting 2 into 50c1 is 50 into 100 raised power 49 plus some integers, this 2 multiplied by this term plus some integers, right? You're getting this kind of thing. So 2 into 50 is 100, 100 into 100 raised power 49, that is 100 raised power 50 plus some integers. So 101 raised power 50 minus 99 raised power 50 equals to this. Basically 101 raised power 50 equals to 100 raised power 50 plus 99 raised power 50 plus some additional integers I. Now we can clearly see that 101 raised power 50 is greater than 100 raised power 50 plus 99 raised power 50 because we have some additional terms over here for 101 raised power 50, right? So this is how you have to do it. Think in terms of 1 plus x and 1 minus x, doing addition subtraction, and that would fetch you the answer.
And now let's talk about series expansion and their notations. Although we have talked about them in previous lectures, but let's talk about them in a different manner this time. So the first one over here is 1 plus x raised power n, and let's expand that with the help of binomial theorem, right? This becomes nc0 dot 1 raised power n dot x raised power 0 plus nc1 dot 1 raised power n minus 1 dot x raised power 1 plus nc2 dot 1 raised power n minus 2 dot x raised power 2 till ncn dot 1 raised power 0 dot x raised power n. Okay. To further simplify this one, we'll be getting 1 plus x raised power n equals to nc0 dot 1 dot 1, this is 1, this is 1, plus nc1 dot 1 dot x, this is 1, this is x, plus nc2 dot 1 dot x square till ncn dot 1 dot x raised power n, right? Now, to further simplify this one, this will be written as C0, this will be written as C1. So basically, from now onwards, we'll be writing this notation as C0, this as C1, this as C2, or and so on. Okay. So this ultimately becomes 1 plus x raised power n equals to C0 plus C1x plus C2x square plus C3x cube till Cn x raised power n. And you have to remember this series. Okay. So whenever someone says 1 plus x raised power n, this should pop up in your mind, right? Not this one, this one. Okay. Now if you talk about 1 minus x raised power n, for that, we'll be writing 1 plus x raised power n once again. We have c0 plus c1x plus c2x square plus c3x cube till cn x raised power n, right? And now we'll replace x with minus x. So this becomes c0 plus c1 minus x plus c2 minus x square plus c3 minus x cube till cn minus x raised power n. So this actually becomes c0 minus c1x plus c2x square minus c3x cube plus c4x4 till cn minus x is power n. So basically we have alternate plus minus signs, plus minus plus minus. Okay, this is our 1 minus x is power n. Now if we talk about x plus 1 and x minus 1 raised power n, in that case x plus 1 raised power n would be c0 x raised power n. Why? Because in the expansion over here 1 was coming, 1 raised power n. In this case x is coming, so x raised power n. Okay. So c0 x raised power n plus c1 x raised power n minus 1 plus c2 x raised power n minus 2 till cn x raised power 0 or nothing basically. Okay. This is our x plus 1 raised power n. And now if we talk about x minus 1 raised power n, you can keep that as homework. Just derive that and learn that, right? You have to remember all these series, okay, on your tips, right? And now let's talk about fifth, sixth, and seventh. So the fifth one is C0 plus C1 plus C2 till Cn, that is equals to 2 raised power n. So for that, we'll again be utilizing 1 plus x raised power n. That is C0 plus C1x plus C2x square plus C3x cube till Cn x raised power n, right? Now if you put x equals to 1 over here, you'll be getting 2 raised power n equals to C0 plus C1 plus C2 plus C3 till Cn, right? So you have to remember this one. Now, if we talk about sixth one, that is C0 plus C2 plus C4 till the end, that is equals to 2 raised power n minus 1. Now, we can see that we are adding up terms with even super subscripts. Okay, C0, C2, C4, C6 till the end, right? So, for that, we'll again be utilizing 1 plus x raised power n. Now, that is C0 plus C1x plus C2x square plus C3x cube till Cn x raised power n, right? Now, if you put x equals to 1 over here, you'll be getting 2 raised power n equals to C0 plus C1 plus C2 plus C3 till Cn. That is our first equation. Now, if we talk about 1 minus x raised power n, that would be C0 minus C1x plus C2x square minus C3x cube till Cn minus x raised power n. Okay. If you put x equals to 1 over here, you'll be getting 0, right? Equals to C0 minus C1 plus C2 minus C3 till the end, that is Cn minus 1 raised power n. Okay. Now this is our second equation. If you add first and second, what you'll be getting? 2 raised power n equals to 2 times C0. This and this gets cancelled out. Plus 2 times C2 plus 2 times C4 till the end. Okay. Now 2 raised power n by 2 equals to C0 plus C2 plus C4 plus C6 till the end. So this becomes 2 raised power n minus 1, right? You again have to remember this one as well. Okay. Now if we talk about the last one, that is C1 plus C3 plus C5 equals to 2 raised power n minus 1. In this case, again, you have to subtract 1 and 2, right? Because in this case, even subscripts would get cancelled up and odd subscripts would get doubled up, right? So you'll again get the same result. So I'll keep seventh one as homework. Okay, it's very simple. You just have to subtract 1 and 2 and you'll get the answer. Okay. And now let's solve this example. The sum of the series 20C0 minus 20C1 plus 20C2 minus 20C3 till 20C10, not 20C0. It's not till the end. It's somewhere in middle, right? 20C10, right? So if we write down this in the notation format, we'll be getting C0 minus C1 plus C2 minus C3 till C10. This is what they're asking, right? Now we can see alternating plus minus plus minus. So we know that we have to use 1 minus x is per 20. Now this is what? This is C0 minus C1x plus C2x square minus C3 x cube plus C4 x is per 4 till C20 x is per 20. Agreed? Right? Now if you put x equals to 1 over here, we'll be getting 0 equals to C0 minus C1 plus C2 minus C3 plus C4 minus C5 plus C6 minus C7 plus C8 minus C9 plus C10 minus C11 plus C12 minus C13 plus C14 minus C15 plus C16 minus C17 plus C18 minus C19 plus C20. Okay. Now, can we say that C0 is same as C20? Why? Because NCR equals to NCN minus R. We know this property, right? Since NCR equals to NCN minus R, we can say that 20C0 is same as 20C20, right? So we can write this as 2 times C0, right? This one 2 times C0 minus 2 times C1, right? This one and this one. C1 is same as C19. Similarly, we can write down till C2 minus C3 plus C4 minus C5 plus C6 minus C7 plus C8 minus C9, right? We can see C2, C18, C3, C17, C4, C16, 5, 15, 6, 14, 7, 8, 13, 8, 12, and 9, 11. This one is still left, right? This one is left. It has no pair. So basically, we are getting 0 equals to this plus C10. Okay. So what if we add C10 over here? So this becomes 2 times C10. So we can club it over here. right? So basically C10 by 2 gives us C0 minus C1 plus C2 minus C3 till C10. Okay, this is our answer. So 1 by 2, 20 C10. D is the correct answer, right? So today's lecture was still here only, and in the next lecture, we'll be talking more about series expansion. So let's meet in the next lecture. Thanks for watching.